Hi, my name is Chengxi, 12 years old. For this lesson, we'll be continuing on with the techniques and applications for definite integration. So for this lesson of definite integration, we have this example over here, which is double integration on x square root y d sigma, where as the d basically the boundary. So where d is bounded by y equals to square root x and y equals to x squared. So first, we are going to draw the graph. So if we're going to draw the graph over here, what we're going to have is okay, so what we'll have over here, so first of all we have y is equals to square root x. So over here y is equal to square root x is basically like this, okay? And then, so this is y equals to square root x, and then we have y is equals to x squared, which is like somewhat like this, okay? So and thus the area bounded is basically this part, okay? So for this part, what we're going to have here is that, so for this question, we have x square root y. So first of all, we obviously know that for this part, it is a dx dy, right? But which one do we here integrate with respect to first? But you see over here, you can integrate either with respect to first, but over here we're going to stick with integrating with respect to x first, because why not? So the y part will not be needed and will be placed behind. Well, for this question, you can choose to do integrate with respect to x first or y first. Both works, okay? So for this part over here, what we're going to have is that, so x, so if we're doing it with respect to x first, this part over here, what we're going to have is that x will be equals to y squared for this part, and over here x will be equal to square root y. So it will be going from y squared, so as you can see it's like this, so it goes from y squared to square root y. Then what about for y itself? So over here, y equals to x squared has to be, so it's at the point of interceptions, whereas y equals to x squared is basically saying that the only two times that x squared is actually equals to x is when x is equals to 0 or x is equals to 1, and showing that for this part over here the point of interception for x is 1, while for y if you do it too, it will be the same result. So for y it will be from 0 to 1. Okay, so now that we have gotten this part, we can integrate x already. Whereas we are going to get, so x half x squared y squared to square root y dy. Then after that, for this part, what we're going to have is, So this, if you substitute, you can substitute both inside. So first, if you substitute square y inside, you're going to get y dy. While on the other hand, if you substitute y square inside, so here minus because of those boundaries, okay? So if you substitute y square first, then what you're going to have is y to the power of 5 over 2 basically. And you can integrate for both of them already. Give me a sec. Wait, hold on. Let me just take a quick look. Oh, whoops. So for this part, whoops. So for this part, there's a square here. So the square for this part, this will end up with y, and here you have 3 over 2. While for this part, have y to the power of 4, which we're going to get 9 over 2. Sorry for that just now. So 9 over 2 dy, and then now we can integrate for both sides already, whereas you can get 1 over 2 times 2 over 3 y to the 2 over 5 to the power of 5 over 2. And then after that we substitute from 0 to 1 and then minus 1 over 2, so once you integrate it, it will become 2 over 11, y to the power of 11 over 2 from 0 to 1, whereas you can simplify the 2's for both of these parts. And you'll get, so here you have 1 over 5, y to the power of y over 2, and then the y over 2, if you substitute 1 inside, it will just stay as 1 over 5, but if you substitute 0 inside, you're going to get 0, so you can ignore it. While for this part, you're just going to get 1 over 11 over here. Okay, so what is 1 over 5 minus 1 over 11? So here you have 55. Basically like whereas you're going to get a 6 over 11. Okay, so that will be our answer for this example. So what we mainly did for 6 over 55. So for this example over here, what we mainly did was just has to integrate with respect to x first, then after that we just kept integrating and we minused. Well, if we want to do it with respect to y first, with the y to the power of 1 over 2 becoming 3 over 2, and then you have the x-axis and then with respect to x, well, that's your choice. But for this lesson, we'll be doing for this part, okay? So now we're going to be moving on. Moving on to our next example, we're going to have this over here. First, let's see. We have double integration. Boundary is x squared plus y squared is bigger or equals to 1 and smaller or equals to 4. And then the function is square root x squared plus y squared dx dy. So let's first draw out the graph. Okay, so over here for this part, we have the larger circle, which is going to be here, x squared plus y squared is equals to 4. Because this is the outline, so it's not going to be the smaller or equals to. So here the bigger circle, whereas here the radius is 4. And then we'll also, I mean 2, sorry, because that the r squared is 4, so the radius is basically 2. So what we have here is like this, okay? So what we have is the bigger circle being here x squared plus y squared is equals to 4, which is 2 squared, and we will also have x squared plus y squared is equals to 1 as the smaller circle, okay? So we're going to have like this, okay? So this will be the outline for x squared plus y squared is equals to 1. Basically the square, 1 is basically the square of itself already, okay? Like this. So the area bounded is basically here the space between these two circles. Okay, now that we have already drawn the model, what we're going to have here is, so for this part, so we have to change from Cartesian coordinates to polar coordinates, whereas we already know what the boundaries are. So for this part, what we have, first we need to see this part in order to tell if we are going to integrate with respect to x or first, or with respect to theta first. So what we're going to have here is x squared plus y squared, and since x is equals to r cosine theta and y is equals to r sine theta, so for this part what we're going to have is r squared cosine square theta plus sine square theta or sine square theta d. So over here, later then I'll tell which one we will integrate with respect to first. So for the r, what we're going to have is definitely from 1 to 2. So r will be from 1 to 2, while theta being the full circle, it will be from 0 to 2 pi. And here, when we change to polar coordinates, we have the r d theta. So over here, for this we can take out the r squared for this part, and we'll have r squared cosine square theta plus sine square theta. So apparently over here, cosine square theta plus sine square theta is basically here 1, right? So we are going to use that. So these two add together will become 1, and we'll get a square root r squared, which you are going to end up with the r. So you're going to have r squared dr d theta. Well, this shows that even if we integrate with respect to r first, or when we integrate with respect to theta first, you can do both. Well, for this part over here, this you can separate it to iterated integrations and all. So for this, for the r, we can already integrate it just like how we can already integrate the theta. So for the r, we can integrate it and we will get 1 over 3 r cubed. And we'll have to sub in the boundaries from 1 to 2. And we'll also have to times the theta, whereas when you integrate it, you're going to have theta, and it'll be from 0 to 2 pi. So over here for this part, if you sub the 2 in, what you're going to get is, so it'll become 8 over 3, and it'll minus this 1, so 1 cubed will still be 1, which is 1 over 3. And you have a 2 pi at the back, while the 0, you just ignore it, because if you times it, it will just end up being 0. And now that you have gotten this part, you have 7 over 3 times 2 pi, which you will end up with 14 pi over 3. And that will be our answer for our second example. So over here, this is basically the whole example for this question. And for this lesson, we mainly just had the two examples where we can we can integrate with respect to r or theta first. Either of them both can. And that will be all for this lesson. Last but not least, thank you for your watching.